Alright, today we're solving Leetcode's best time to buy and sell stock. You are given an array of prices where the value is the price of a given stock on the ith day. You want to maximize your profit by choosing a single day to buy one stock and choosing a different day in the future to sell that stock. Return the maximum profit you can achieve from this transaction. If you cannot achieve any profit, return 0. Example 1, we have an output of 5 because if you buy on day 2 at a price of 1 and sell on day 5 at a price of 6, you get a profit of 5. Note that buying on day 2 and selling on day 1 is not allowed because you must buy before you sell. Example 2, we have an output of 0 because on day 1 we have a price of 7 and the numbers all descend in order. Therefore, if we were to sell on any of the following days, we would be selling at a loss, or in other words, we would not be making any profit, so we return 0. In order to solve this, we're going to utilize some dynamic programming, and this solution will have a big O of n time complexity and constant space complexity. If you're not too familiar with dynamic programming, the general idea is to use previous knowledge as much as possible when iterating through a process. This will allow us to traverse the array only once, giving us our linear time complexity. So here we have example 1 set up in the notepad. There are really only two variables that we need to track: the current minimum buy price and the maximum profit so far that we've encountered. We'll start by initializing the current minimum buy price with the first price in the input array, which is 7. Then we'll initialize the maximum profit so far with 0, because when we first start we haven't sold anything, so we don't have a profit yet. Next we'll iterate through our array, starting at the second day, aka the first index. We start here because we cannot buy and sell on the same day, so we can't start it on the 0 index. We have a current price of 1. The first thing we'll do is check which price is lower, our current price or our current minimum buy price of 7. Of course 1 is less than 7, so we update the current minimum buy price to 1. Then we'll check if the current price is equal to the current minimum buy price. If it is, then we'll just continue because, again, we're not allowed to buy and sell on the same day. And even if they weren't the same day, let's say we just had some duplicates, well, the result is going to be the same. So we can just continue and force the for loop to iterate. So the for loop iterates to day 3 and we have a price of 5. We compare our current minimum buy price of 1 to the current price of 5 and we keep 1 as the current minimum buy price. The current price does not equal the current minimum buy price, so the if condition does not trigger. Next, we'll calculate the current profit by taking our current price and subtracting the current minimum buy price from it. So 5 minus 1 gives us a sell profit of 4. And all that's left to do is compare the current profit to our maximum profit so far, and we'll assign the greater of the two values to maximum profit so far. In this case, 4 is greater than 0, so our new maximum profit so far becomes 4. The loop iterates to day 4 where we have a price of 3. Our current minimum buy price stays at 1. The if condition evaluates to false. 3 minus 1 gives us a current profit of 2. So our maximum profit so far stays at 4 and the loop iterates. Day 5, we have a price of 6. Our current minimum buy price stays at 1. Our if condition evaluates to false. 6 minus 1 gives us a current profit of 5. 5 is greater than 4, so it gets assigned to maximum profit so far. The loop iterates to day 6 and we have a price of 4. Our current minimum buy price stays at 1. The if condition evaluates to false. 4 minus 1 gives us a current profit of 3. So our maximum profit so far stays at 5, and the loop iterates out of bounds, causing our for loop to exit, and we return a maximum profit of 5. Let's translate this to code. Okay, we'll start by initializing our current minimum buy price with the first price in the array. Then we'll initialize our maximum profit so far with a value of 0. Next, we'll set up our for loop. We'll initialize the index with a value of 1. We'll check that the index is less than the length of our prices array, and then we will increment our index by 1 when the code block is finished executing. We'll store the current price in a variable just for readability purposes. Then we'll compare the current minimum buy price to the current price and assign the lesser of the two to our current minimum buy price. Next, we'll check if the current price is equal to the current minimum buy price. If it is, we're just going to continue. We'll calculate our current profit by taking the current price and subtracting the current minimum buy price from it. And then we'll compare the maximum profit so far and the current profit, and we'll assign the greater of the two to maximum profit so far. And once we exit our for loop, we're just going to return the maximum profit so far. And that's our solution. Let's copy and paste this in a Leetcode. Okay, let's paste it in here. Hit submit. And we get an accepted solution. Thank you for watching.